Alright, this is the notes for section 6.5, completing the square. When we're done with this section, what we really want to be able to do is we're going to use two methods to be able to change from standard form to vertex form. Now, we learned last section 6.4 how to go from vertex form to standard, so we want to go back the other way this time. To begin with, we're going to look at completing the square, and completing the square is where we're going to use the binomial square theorem to help us do that. So if you think about our binomial square theorem, we learned back in section 6.1 that a plus b squared can be written like this: the first term squared, a squared, the last term squared, b squared, and in the middle was always 2 times a times b. So what we're going to be able to do is we want to be able to take two of those terms and be able to figure out what this third one's going to be, this b squared portion. So we're going to take a look at an example using that in just a second. Alright, so let's look at this example. It says, what number should be added to x squared plus 14x to make a perfect square trinomial, and write the perfect square trinomial as a square of binomial. So here's what we have. We want to write it in the form a plus b squared. And we want to finish off this, a squared plus 2ab plus b squared. Okay? Well, here's what we have. We don't know what a and b are, but we know the first term here is x squared, and the second term here is 14x. Well, if a squared is equal to x squared, that's like saying that x and a are equal to each other. So that means 2ab, a is x, so 2b would have to be 14. So that means b would have to be half of 14, or 7. Well, if I square 7, that makes this 49. So what would a and b have to be? Well, a would have to be x, and b would have to be 7. So we can write that as x plus 7 squared. Alright, this leads to what we call the completing the square theorem, and it just says the following. If we have x squared plus bx, if we want to complete that square, we want to make a perfect square trinomial, all we need to do is take this b value, divide it in half, and square it. So in other words, if I have something like this, x squared plus, let's say 12x, we're going to take half of this middle term, which would be 6, and square it, which would be 36, and we have a perfect square trinomial, which I could then write as x plus 6 quantity squared, using the binomial square theorem. As I mentioned at the very beginning of the video, our main purpose, or the main goal that we have in this section, is to be able to convert any quadratic that's in standard form and put it in vertex form, because remember, in vertex form we can easily find the vertex of our parabola. So what I want to do is I want to look at two different methods of doing that, and this idea of being able to convert back and forth between the two forms is going to be kind of some key level 1 stuff that you'll have to be able to do in this unit. So what I want to do first of all is I want to look at using the completing the square method to write something in vertex. Alright, so the first method that we're going to use for making this conversion to vertex form is the completing the square method. And basically, using the completing the square method, what I want to do is I want to get one side of my equation to look like this: x squared plus bx. Now by doing that, that's going to allow us to use the completing the square theorem, because one side will look just like this. I will be able to add this on and then complete the square. So let's do that with this particular example. So we have y equals x squared plus 10x minus 4. The first thing I'm going to do is I want to get rid of the minus 4, because I want x squared plus bx. So I'm going to add 4 to both sides. If I do that, I have y plus 4 is equal to x squared plus 10x. Now I have exactly what I wanted on that side, that x squared plus bx. Now I can complete the square by taking half of b and squaring it. So half of 10 is 5. 5 squared is 25. So that would be 25 here. Now the next thing I'm going to do is I'm going to take this and write it as a square of a binomial. And I can do that by saying it's x plus 5 quantity squared. So in other words, it will always be half of whatever this b term is. The sign, remember, is going to be dependent on this sign right here. If it's positive, this will be positive. If it's negative, this will be negative. And then over here, I still have y plus 4. And you'll notice now that the form that I have is in vertex form, exactly the same as what we have right up here. So we can easily find our vertex, and our vertex then for this one would be the vertex point -5, 4. I'm sorry, -5, -4. So this first method, the completing the square method, works best is if we have the value, the a value that comes in front of x squared is 1. So notice how I have a 1. This is like a 1 there. So when we have something like this, this completing the square method works really well. Now if we don't have that, we would want to go to method 2, and we can actually use method 2 for any form here. But let's go on and see if we can take a look at method 2 and how we can use this a little bit differently as well. All right, method 2 is probably the method that we're going to end up using the most, and usually I'll refer to this as my negative b over 2a method. And basically it takes the idea that we learned in 6.4 about if we were to take go from vertex form to standard form, and I just kept the a, b, or a, h, and k in my answer, you'll notice that if you think about it now, standard form is this: y equals ax squared plus bx plus c. That means that a is the same in both forms. It means that this, and this is going to be the key for what we're doing right now, is our b value, -2ah, and then this stuff right here is our c value. But this -2ah gives us a connection between b and h. So what that means is that b is equal to -2ah. Well, if I solve this for h, what that means is the vertex, the x value of our vertex, will always be -b over 2a. So in method 2, what we're going to do is we're going to use that idea to help us find the vertex and then write it in vertex form. Alright, so let's take a look at this example and see if we can utilize this a little bit. This example, you'll notice I put a star here, and the reason for that is you're going to have to, for level 1 tests, you're going to have to do a problem just like this problem right here. So this is a skill that you're going to have. So it says, first of all, that we want to take this equation, we want to rewrite it in vertex form. Well, to rewrite it in vertex form, what I'm going to do is I'm going to find the x value of my vertex. And remember, the x value of the vertex is our h value in vertex form. Well, we know that that h value is going to be -b over 2a, and that's always the case. So in this particular example, -b over 2a would be -48 over 2 times -16. So that means the h value would be equal to 1.5. So the x value of my vertex is 1.5. So now think about it. We want to write this in vertex form. So I have, remember, that's y minus k equals a times x minus h, quantity squared. Well, there's 3 numbers I need to figure out. What is h? Which I just figured out. What is a? Well, the a value is always going to be the same whether it's in standard form or vertex form. So we know that my a value is -16. The only thing that's left for me to figure out is what is my k value. So now we got to do that. In order to do that, what we're going to do is we're going to take the x value of our vertex, and we want to find the y value of the vertex. So I could do that by taking the x value of the vertex and plugging it in to my equation. So I'm going to plug 1.5 in for x here and solve for y. What that means is if I put 1.5 in here and I solve for y, we'll find that that y value is equal to 42. That means, since h and k are together, that actually means that my k value is 42. So we have our three numbers that we really were looking for, negative 16, 42, and 1.5. So now I'm going to rewrite this equation. Y minus 42 equals negative 16 times x minus 1.5, quantity squared. All right, so our second part of this question says find the maximum height of the ball at the time it takes the ball to reach that point. So the maximum height the ball reaches, well, let's think about this. If you think about graphing this, I'm just going to do a sketch of that graph. Remember that the negative tells it it's going to open downward. We know the plus 6 is our y-intercept. So that c value is always your y-intercept. Okay? So what that means is that the height of the ball when we start is going to be 6 feet off the ground. So this is 6 feet. It's going to go up and then it's going to come down. Well, the highest point that it reaches is the vertex of our parabola. And the vertex of our parabola we know is going to be at the point 1.5, 42. And the x value tells us how long it takes for the ball to reach that height. So how long will it reach that maximum height? 1.5 seconds. And then how high will the ball get? Well, it's going to reach a height of 42. That's my y value. Remember, the y value here is the height of the ball. So it's going to reach a height of 42, and we are talking about feet here. So we're going to say 42 feet would be the maximum height that the ball reaches.